SCI Curious ID presents a deep dive into one of the most visually spectacular and educational chemistry demonstrations known as the elephant's toothpaste reaction. Prepare to be amazed and enlightened by the science behind the spectacle. You've probably seen it, the crazy experiment where colorful foam explodes out of a bottle like a toothpaste tube for giants, shooting meters into the air. But what's actually going on inside that bubbly, rapidly expanding mess? It's more than just a pretty explosion. It's a fascinating chemical process at work.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to Sci Curios, where curiosity meets science.
Let's break down the explosive chemistry behind the elephant's toothpaste reaction. This experiment became famous thanks to YouTube and countless science shows, captivating audiences with its dramatic scale and vibrant colors. It's a staple in classrooms and science fairs, inspiring countless young scientists. It's actually based on a classic chemical reaction used to demonstrate rapid decomposition and gas production. Originally, it was a simple lab test to show how catalysts can speed up chemical reactions, a fundamental concept in chemistry. This controlled process was a cornerstone of early chemical education. Until someone added soap and food coloring, turning it into pure spectacle. The first versions of this enhanced demonstration date back to the mid-20th century, transforming a basic lab procedure into an engaging visual display that captured public imagination. The modern viral form took off when educators used it to make chemistry more exciting for kids. And honestly, who doesn't love a giant foamy explosion that looks like something out of a cartoon? It's a perfect blend of education and entertainment, making complex science accessible and fun. At its core, the elephant's toothpaste reaction uses hydrogen peroxide, yes, the very same antiseptic you find in medicine cabinets for cleaning cuts and scrapes. This common household chemical holds the key to our spectacular foam eruption. When you add a catalyst like potassium iodide or yeast, it rapidly breaks down hydrogen peroxide into water and oxygen gas. The catalyst doesn't get consumed in the reaction, it merely speeds up the process, allowing the decomposition to occur at an astonishing rate. The formula looks like this: 2H2O2 yields 2H2O plus O2. This equation shows 2 molecules of hydrogen peroxide yielding 2 molecules of water and 1 molecule of oxygen gas. The oxygen gas, once released, gets trapped in the added soap, forming millions of bubbles almost instantly, creating the characteristic foam. The heat released makes it an exothermic reaction, so the foam feels noticeably warm to the touch, and sometimes even steam can be seen rising from it. If you've seen the giant outdoor versions, that's just hydrogen peroxide at a much higher concentration, typically 30% or more, compared to the 3% found in household solutions. The more concentrated the hydrogen peroxide, the faster and more dramatic the reaction, producing an even larger column of foam. But that also makes it far more dangerous, which is why professionals handling these higher concentrations wear full protective gear, including heavy-duty gloves, safety goggles, and lab coats to prevent chemical burns. Here's a fun fact. The biggest elephant's toothpaste experiment ever recorded used over 600 liters of hydrogen peroxide. This colossal undertaking required meticulous planning and execution, demonstrating the incredible potential of this reaction on a grand scale. It created a foam column taller than a house, a truly awe-inspiring sight. And yes, it looked like a rainbow monster brushing its teeth. This reaction is a perfect, vivid example of catalytic chemistry in action, showcasing how a small amount of catalyst can drive a massive chemical change. It's the same fundamental principle used in many critical applications, from the catalytic converters in car engines that reduce harmful emissions, to fuel cells generating clean energy, and even within our own bodies, where enzymes act as biological catalysts, facilitating countless biochemical reactions essential for life. The beauty of this experiment lies in its simplicity and power. It turns invisible molecular reactions, which are usually confined to textbooks and abstract concepts, into a huge, tangible, and visually stunning event that anyone can appreciate and understand. Chemists often say it's like watching gas formation in real time, but with a theatrical twist. The elephant's toothpaste reaction reminds us that chemistry isn't just about complex equations and sterile laboratories. It's about dynamic processes that can be both educational and incredibly entertaining. It's about wonder, color, and the joy of discovery, sparking curiosity in everyone who witnesses it. So next time you see that magnificent mountain of foam, remember it's pure science in motion, a vibrant demonstration of chemical principles that are all around us. Stay curious with SCI Curious ID.
Science is everywhere if you just know where to look. Thanks for watching Sci Curious. Until next time.